So we discussed what an identity is, and that is for every value you put into the function, um, that they will be equal no matter what. And again, the equation that is not an identity, so something like 2x plus 1 equals 0, this is known as a conditional because only one such value of x works. Conditional. So bring us back to like the section before, it would say like sine theta plus 1 equals 2, solve. Well, that was a conditional statement because you would get one value for theta that worked. Where here, we're going to have infinite amount of values for theta that will work. So here's how it's going to go. You're given an identity, okay? So here is an identity. We know it's true, so you don't have to like second guess that. This is a true statement. So if I put in pi over 3 into all those thetas, they both will equal each other. Your job as the student is to prove that these are equal. So there's some rules. And so you're going to have homework in my math lab, and then you will also have some handwritten homework for me to check how you're proving these. So the rule is start with the messier side first. So when I look at A, both of them look pretty messy. You know what I mean? None looks more messy than the other. So it does not matter what side. And you could pick the side that's least messy. So for example, like B, the left side is clearly more, lack of a better word, messy. Or looks more challenging. So I would mess with that first because it's easier to clean things up versus expanding them. All right, so it doesn't matter which side, but this technique will really make your life easier. So going back up to A, we are going to go ahead and just start with the left side. All right, here's the other rule you have to follow. And you wish this was not the case because it would make things much easier. You can only manipulate one side. So don't think you can cross multiply this thing. You can't multiply both sides by something. You have to pick a side and you have to keep messing with it until you can get out the other side. All right? Now, you would have not thought about this unless I told you that. Forgive me. You would have not have thought about this technique, which I'm about to use, unless I told you about it, okay? So if you're like, where in the world are you coming up with this stuff? I am giving you a tool right now. Once we do a couple of these together, hopefully this tool will be in your mind so you know when to use it. The thing is I can clearly see that somehow my denominator 1 plus cosine theta turned into sine theta. And the only way I can get there is if I go back up to my cheat sheet. Again, you're going to have that right next to you while you're doing these notes and homework. Here is one way I can get out from cosine to sine. I don't see anything else on my cheat sheet that relates sine and cosine, if that makes sense, except for tangent, but there's no division happening in this problem. Okay, so what I'm going to show you is I'm going to rewrite this. This tells me to multiply the numerator and denominator by 1 minus cosine theta. You won't be given hints after these videos, but this is a good hint and it will come in handy when you're doing other ones. So what I'm going to do is I'm going to rewrite this and I'm going to multiply by 1 minus cosine theta over 1 minus cosine theta. I have not changed the problem at all because I'm still multiplying by 1. And this is just a strategy, so we're building our strategies. And I end up getting, okay, well, I'm going to leave this as is. Maybe I want to multiply it, but I'm just not sure yet. So I like to do this first because sometimes it will save you many steps. And now if you multiply that denominator, we get 1 times 1. We get a plus cosine and a negative cosine, so they cancel. And then we get a negative cosine squared. Going back to our cheat sheet, which I probably should just have next to it instead of going up because I feel like I might make you dizzy. Here we have, well, 1 minus cosine squared theta equals sine squared theta. So I can go ahead and I'm going to go back to my color I've been using. I'm going to replace this with sine squared. All of these steps are valid because all of these things are equivalent. And this is where more of your algebra skills come in. Well, if you have 1 sine in the numerator and sine squared in the denominator, you can reduce one of those out. So you end up getting 1 minus cosine theta over sine theta. And let's check. So I might have to keep going. But if I check with what we started with, we wanted to show this side. So we started playing with that side. Will in fact come out equal to this. Well, isn't that what we got? And so that's why we're done. So I'm going to rewrite what we started with. Just good formatting. So the key thing with these is you know what you're starting with and you know what you need to end with. It is the middle work that's really important. And you must show all of your steps for me to understand that you know what you're doing. So don't assume I know anything, okay? You're writing to a reader like they don't know any of this. Okay, let's do one more example and then we'll take a break and go to the next video. So with B, it's clear to me that that left side is more messy. So I'm going to rewrite the left side. Now it's completely up to you when you're on your own what you want to do. So sometimes you look at these and you're going to be like, oh, it's a no-brainer. I'm going to replace this with that, this with that. And it gets worse and worse and worse. And then you know, okay, let me take a step back and maybe think about what else I can replace. So you just have to kind of roll with the punches with this. Feel uneasy with it. It's okay. So somehow I have to get this thing equal to secant. So one thing I think to do is to rewrite cotangent and tangent in terms of sine and cosine. So cotangent's definition is cosine over sine, and tangent's definition is sine over cosine. Okay, and you could be my guest and go forward and distribute that sine off the bat. The problem is, I know I want to get out one term at the very end of this. So that's my indicator that I should combine these two. And how you do that is you need a common denominator. So I need to multiply this by cosine over cosine. and this by sine over sine. So realize I'm showing that work. So don't jump to the next step without showing that piece. So I get sine theta. Well, I get cosine times cosine, which is cosine squared, plus sine times sine, which is sine squared. And now these are over the same denominator. Order doesn't matter. Okay, this is where it starts to feel a little fun. Don't deny yourself the fun that is here. This piece, what? That is an identity we know. So I know that equals 1. Okay, well now I can multiply it by sine. Because remember, sine is over 1. And then what do we see here? We can reduce those signs out. And we end up getting 1 over cosine. What does that equal to? Oh my gosh, it feels so good. Secant. So what you did is you found that this, you did all this middle work to prove it, in fact, equals secant of theta. So to get you in really good habits, you should rewrite what you started with. And then what you ended up with. Okay, I'll see you in the next video for more examples.